Hello everyone, I'm Francis. This video is introducing how to calculate linear programming by Octave. Agenda. My OS is Zen OS 6.932-bit. Octave version 3.4.3. GNU C++ version is 4.4.7. Okay, I will introduce Octave. GNU Octave scientific programming language, powerful mathematics-oriented syntax with built-in plotting and visualization tool. Free software run on GNU Linux, macOS, BSD, and Windows. Drop-in compatible with many MATLAB scripts. The syntax example, the Octave syntax is large. Compatible with MATLAB, the Octave interpreter can be run in GUI mode as a console or invoked as a part of a shell script. More Octave examples can be found in the wiki. Okay, I will introduce the objective function. The objective function output 1 is the output number of each process step. Output 2 is the output number of weekly process step. Output 3 is the output number of AEI after each inspection process step. Mathematical model is maximum output function. Okay, this is a function. And then we have the subject. Okay, this is a subject. And I will introduce the Octave GOPK function. Okay, here is Octave. My Octave is the bin is in the user local bin. Okay, we just type the Octave and execute it. This is Octave. And we type the help GLPK function. Okay, it shows the GOPK function. Help GOPK function. It solves a linear programming using the GNU GOPK library. Give 3 arguments. GOPK solves the following standard linear programming. For example, the minima C multiply X, and there's 2 subjects. A multiply X equal B, X greater than 0. And we can also use another, but many also solve a problem of the form. You can use the minima or maxima. And C multiply X and subject to A multiply X equal over less equal or greater equal than B, and A is greater than low bound and S less than the low bound. Okay, it is a GOPK function, and it has many description, and let us see the description. You can see the input arguments. The input argument is C, A, B, low bound, upper bound. Okay, we can fast to see the example. There is an example in the last. Here is an example. Okay. Okay, here is the example. So we just need to define the C, A, B, low bound, upper bound, C type, var type, S, and the parameters. Okay, and the C, A, B, low bound, upper bound, C type, var type, S. And this is parameter message level, and this is parameter iteration limitation. We just using the example is enough. And I will show you the C-type. C-type is UUU. What does it mean? C-type. You can see the C-type in the upper. Okay, here is the C-type. C-type, an array of characters containing the sense of each constraint in the constraint matrix. Each element of an array may be one of the following values. For example, F, a free constraint, U, an equality constraint with an upper bound, S, an equality constraint, L, an inequality with a low bound, D, an inequality constraint with both upper bound and low bound. Okay, we also need to understand the var type. The var type is a current array containing the type of the variable. C means a continuous variable. I means an integer variable. Okay, sense. Sense. If sense is 1, the problem is a minimization. If sense is -1, the problem is a maximization. The default value is 1. So you can see in the very beginning, okay, in the very beginning we have the introduce. You can see here is the minima. Okay, the default value is 1. -1, it means this is a maximization problem. Okay, iteration limitation. And we also need to understand the iteration limitation. Okay, here is a parameter. And the parameter, you can see the message label. The message label 0 means no output, 1 means error message only, 2 means normal output, 3 means full output, include information, no message. Okay, here iteration limit. Simplest iterations limit, if this value is positive, it is decreased by 1 each time when one simple iteration has been performed, and reaching 0 value signals the solver to stop the search. Negative value means no iteration limit. Okay, and there also have many parameters, and you can study it by yourself. And we were using the Octave GOPK function to calculate the linear programming. Okay, we have the open the Octave. Okay, we should declare the function. You can see the function here. C. C is the function. And now I'm using F. Sorry. Original is C. Now I'm using F. The F function. This is more appropriate to understanding F. And F is here. Okay, we should declare the f function. F is a matrix. $2,000, $100, $1,500, $1,600. Okay, this is f function. Now we should declare the a. The a means a also is a matrix, or a is also a matrix. A equal 50, 30, 30, and next 2, 3, 2, and next you can see the next 1, 1, 1, 1, 1, 1. Okay, here is a matrix over the coefficient. You can see the subject coefficient is here, and we just type in here. And there is no low bound and upper bound. So the LB value, low bound, is empty, and the upper bound is also empty. Oh, LB typo. LB is empty. Okay. Okay, we declare the function a, b, or b should be lowercase. Let me check a. Oh, we forget the b. Okay, b. What is b? B equal. Here, b is those value. Okay, this is b. And we need a C type. This type is this type is UUL. This type, C type. I just enter it, UUL, right? So we just declare the C type. Enter UUL. And we need to declare the var type. The variable data type is because operator 1, operator 2, and operator 3 are greater than 0. So it is integer. Integer. Okay. Enter. You just need the s value. Now we want to find the maxima. You can see we want to find the maxima output. So we need to declare the s value as minus 1. And then we need to use the parameter. Parameter, we should output parameter message label param 点 dot msgle v equal, we need the normal output true, and we need to set that iteration limited as -1, and it means there is no iteration limit. Okay, we just calculate the result. Copy, paste. We just need the true output is enough. Just paste here. Oh. Now we change it to the maxima because our example is a maxima output. And we also need the copy GOPK function. Copy. Okay, here is the result. Okay, this is output 1. Output 1 result is 35, and the output 2 result is 0. Output 3 result is 0, and the maximum output is 70,000. This is the maximum output. Okay, so this is a way to calculate linear programming by Octave. And then I will introduce if we are using the script and using the CPP function to calculate. We can develop a script, and this script I call the linear programming in here. And we also need the GOPK function in here. And I also declare the result output. Remember, the result output 1, result output 2, result output 3, and the result output 4 is the Octave list. Okay, this is a list data type. And you can see after the GOPK calculation, it will return the result to the XMIM, and it returns the result to FMX. Okay, we just assign the value. SMIM is result output 1, SMIM2 is result output 2, SMIM3 is result output 3, the FMax is result output 4, and finally we just display the linear programming .m script function result. Okay. Okay, you can see the linear programming functions in here. Okay, linear programming function here. We need using the run LIN. Okay, we just run it. And then you can see I changed the input parameter. You can see this script function, I call it message label. I assign the message label to the parameter msg label and the iteration limiter assigned to the parameter iteration limiter. And then the parameter will input to the GOPK function. So we need to another two MSG level MSG level equal 2, and then we have the itlin, we set it as -1. Okay. And then we execute the program. Okay, you can see this is the output over the script function. Okay, the value result output 1 is 35. The value of result 2 is 0. Okay, you can see the function. So this is a linear programming.n function result. And we also can use the C programming to call this script function. So I will introduce the linear programming.cpp function, and you can see the code first. Here is the linear programming.n function. We should assign it here. Okay, let's read the code in the very beginning. We need to include the IO string and include the Octave header files. Those are Octave header files, and we have we need using the namespace std, and I also write the linear programming. The problems in here. I just write in the command. Okay, here I declare the maximum output function coefficient. You can see 1500, but 1500. 1600. Okay, it is equal z here. You can see the function. It is equal here. And we need have the coefficient constraint. You can see the coefficient constraint 50, 30, 30. Okay, you can see the 50, 30, 30. And it is 2, 3, 2. Okay, 2, 3, 2. And 1, 1, 1. You can see the 1, 1, 1. Okay, and it is a matrix. Same as a matrix. Okay, constraint coefficient and right hand side value for each constraint. The right hand side value for each constraint you can see 2070, 30. Here's the right hand side value for each constraint 2070, 30. Okay, you can see it is B matrix, and there is no low bound and upper bound, so we just let the low bound and the upper bound empty. Same as here, the code is here. You can see LB. Okay, it's empty, and the upper bound should be also empty. And then we just have the Octave main function assigned true, and the argue vector and the embedded is true, and declare an Octave value list. I call the function arguments. I declare the function arguments, and you have is 1, 2, 3, 4 until 9. Yes, because here you have is 9 parameters in here, and the parameter in here it actually has 2, so I separate it, becomes A and 9 parameter. Okay, assign the parameter, and then we are using the function evaluation. This is a function evaluation, and assign the function name and the function arguments. You can see the function arguments. Okay, function argument, we have 9 function arguments in here, and says a knock out return, means return the number of output. And finally, we printed the linear programming.cpp result of the 1, 2, 3, the value, and the maximum output. Okay, this is CPP code. We see the Makefile. You should install the Octave. Okay, we have quit. You can see after we install the Octave, the lib path. Here is a lib path, and we will use the Octave integer p interpreter. Sorry. Yeah, we need using the lib Octave interpreter.so. We need this file. And the header file is in here. Copy header file. Paste. Oh. This is Octave header file. How to get a header file? And you should using the yam and install Octave. Yeah, after you install the Octave developer package, it will have the header file. Remember, you should install the Octave developer package. Okay, we make the file and we run the shell script. Okay, you can see the result. The linear programming.n function result is here, and the linear programming.cpp function CPP result is here. So you can see the code. The code is evaluate the linear programming function, and then come to here to print the .n function result, and then print the linear programming CPP result. Okay, here is the result. The execution logic is linear programming .sh launches the linear programming, and then linear programming invokes the linear programming.n. Okay, this is videos how to calculate the linear programming by Octave, and you can also develop a C++ program to code the script function to calculate the linear programming. Thank you for watching this video. Bye bye.